students, welcome to Medical Mental Gym Exam Focus Revision. Today we'll be looking at cell wall synthesis inhibitors, specifically penicillins. At the end of this presentation, we should be able to explain the structure-activity relationship of penicillins, give solutions to penicillin problems, and 3, structurally show the mechanism of action. Okay, so penicillins are antibacterial agents which inhibit bacterial cell wall synthesis. So here is the general structure of penicillins. Okay, so we have a thiazolidine ring right there. Allow me just to change color. Okay, so we have got a thiazolidine right there, and then we have a carboxylic acid chain right there, and we have a beta-lactam ring, and lastly we have the acylamine side chain, and the four-membered beta-lactam and the four fused to a 5-membered ring. Together we call it as a bicyclic ring system. Okay, so we are now looking at the structure-activity relationship, which is brain focus number 1. So we have to focus deeply on this structure and its components. So at position number 1, we have got a sulfur. Okay, a sulfur which is not really essential. It can be replaced by nitrogen, oxygen, or carbon. Then at position 2, we have got methyl groups, which are essential. Any substitution at position 2 will result in reduced activity. Position 3, we have a free carboxylate, which is essential for product formation and also for transcriptase interaction. Okay, at position number 4 is a must and should not be tampered with. And we have a carbonyl group just right there, which is essential, and it is the position where the initiation for mechanism of action occurs. Also transcriptase enzyme and also nucleophilic attack. Then we have the cis stoichiochemistry, which is essential. Any substitution at this position will result in reduced activity. Then we also have the acylamine, which is responsible for activity. Okay, so then the bicycling system itself is essential. Why? Because it increases ring strength, okay, and also increases the activity, and the separation of 2 rings will result in reduced activity. Okay, so penicillins have got 3 main problems. Number 1, acid sensitivity. Beta-lactam is sensitivity, and also limited breadth of activity. So we need to sort out these problems. So problem number 1, we have acid sensitivity, which under acid sensitivity we have got ring strain, high reactive carbonyl group, neighboring group participation. So these are factors which are related to acid sensitivity. Okay, even in an exam, when the question says highlight the factors that are associated with acid sensitivity, these are the factors mentioned, and explain them. Now let us delve deeper in them and explain them. So ring strain number 1. So the bicyclic ring system consists of a 4-membered ring fused to a 5-membered ring, as you can see. As a result, penicillin suffers large angle and tensional strains. So acid catalyzed ring system ring opening relieves these strains by breaking open the more highly strained beta-lactam ring. And exactly here is how it happens. So under acidic environment, water attacks the highly reactive carbonyl. Okay, as a result, the ring opens, as you can see. Okay, then we have a highly reactive beta-lactam carbonyl group. Now, the carbonyl group in the beta-lactam ring is highly susceptible to nucleophiles and does not behave like a normal tertiary amide. Okay, so now this amide, now the question arises to say, how does a normal amide behave? So this is exactly what I'm trying to explain. Okay, how does a normal tertiary amide behave? So follow closely as I explain. So the normal amide, when you look at the nitrogen right there, the nitrogen can feed its lone pairs of electrons into the carbonyl group to form a dipolar resonance structure with bond angle of 120 degrees, as you've seen there. Okay, now this process, this stabilization is impossible in the beta-lactam ring because of the increase in angle strain. So it is impossible. Okay, so the resonance stabilization is impossible for the beta-lactam ring because of the increase in angle strain. That would result in forming a double bond within a 4-membered beta-lactam ring, okay, constrained to 90 degrees. When you check the structure, you discover that that is 90 degrees and not 120 degrees. Okay, so this process is impossible. Then influence of the acyl side chain, neighboring group participation. Okay, in other words, it goes through self-destruction. Okay, so the structure demonstrates, the structure you're saying demonstrates how the neighboring acyl group can actively participate in mechanism to open up the beta-lactam ring. Okay, so it goes through self-destruction mechanism. Okay, so we've looked at 3 main factors under acid sensitivity. Number 1, ring strain, a highly reactive beta-lactam carbonyl group, influence of the acyl side chain group participation. Now, listen to me, okay? So follow closely. So nothing can be done to the first 2 factors. Ring strain, high reactive beta-lactam carbonyl. Nothing can be done to that. Only the 3rd factor, which is influence of acyl side chain group participation. The task that we have is reducing the amount of neighboring group participation taking place. Okay, so this is achieved by adding an electron withdrawing group in the side chain, which could draw electrons away from the carbonyl oxygen. Okay, yeah, so from the carbonyl carbon, and reduce its tendency to act as a nucleophile as it's happening there. Yes, so this is all about this part. Now, brain focus. Right. So with the aid of a diagram, discuss in brief the structure activity relationship of penicillins. what are the factors that cause active sensitivity of penicillins? So now, you see, this is how the question would come. So just pause and answer the question. Now you get the answer. Okay? Now, let us proceed to looking at structure, analysis, and problem solving. So this is a benzopenicillin. So the benzopenicillin, number one, it is acid unstable, oral inactive. Why? It has no electron withdrawing group in it. And it is beta-lactamase sensitive. Why are we saying so? Because it has no bulk group. Nothing is shielding it. So if we have a beta-lactamase enzyme, it is able to inactivate the system so easily. Now, what is the solution to this? Let's go ahead and see how we can sort out this issue. So we have the phenoxymethylpenicillin right there, which is acid stable, and previously we had an acid unstable. Now, what has been done for it to be acid stable and to be orally active? So number one, there has been an introduction of an electron withdrawing group, which is a phenox group, which is drawing electrons, which withdraws electrons, decreasing electron density at the carbonyl carbon, making the drug orally active. Now, it is beta-lactamase sensitive, which means nothing has been done to the ring. We still have a problem to sort out. Let's proceed. So we have the methicillin, which is acid unstable, orally inactive. We go back to the same problem now, the one we had earlier. Okay, beta-lactamase resistant. Now we have a solution for the other part, which is beta-lactamase resistant. But then what has been done when you observe? Okay, so yes, what you've said is right. We have an introduction of bulk group right there. You're following closely. Okay, now placing a bulky group on the side chain prevents the beta-lactamase enzyme to reach the beta-lactam active site. The bulk group should not be too big or too small, but should be large enough to escape the beta-lactamase, but sufficiently small to allow the penicillin to bind to its target. That's it. Now we have a problem. It is orally unstable, so it cannot be given orally. Then we have methicillin, which applies same to the methicillin. Here we have a steric, we have a bulk group which is acting as steric hindrance there, so beta-lactam resistant, acid unstable. Okay, now we have oxacillin. Okay, oxacillin, as you can see, so oxacillin has got a bulk electron withdrawing group right there. Okay, which is making it to be acid stable, orally active, and also beta-lactamase stable. Perfect. Okay, next. Then same applies to clozacillin. Okay, next. Same applies to clozacillin. It has got a bulk electron withdrawing group right there. Okay, making acid stable and beta-lactamase resistant. And we have lastly dicloxacillin, which has got a bulk electron withdrawing group right there. Okay, making it acid stable, oral active, beta-lactamase resistant. So for today, this is where we end. Please like and subscribe to the Medical Mental Gym YouTube channel for more of such content. Bye bye, see you next time.